explain what our load diagram for mini project, which is an install mapping for footsteps. Okay. For this, I will explain the input of this project, which is FSR sensor. Okay, as we all know, FSR or force sensitive sensor is a sensor that will detect the change of force using pressure or stress. But in this project, we will apply pressure to the FSR. This project, we will use for FSR sensors, which two are in the front, one at the middle, and one at the heel of the footsteps. Okay, so why we use FSR? Because in this project, we will use pressure to sense or detect the value of pressure, like how much we press our feet on the ground, and how much we put on the insole. So when we apply the sensor from our footsteps, the pressure will detect how much force we apply to that, and it will send an analog signal, which is a signal from 1 to 10 or 1 to something else. Then it will send to a microprocessor or microcontroller, which is we put the SP32. So I will conclude that FSR is an input, like I said earlier. So for this, I think that's all. For one more sensor, which is LM35 sensor, I will put on another person. Okay, so thank you.
Assalamualaikum warahmatullahi wabarakatuh. My name is Dennis Faris. So for my part, I will talk about LM35 sensor. LM35 sensor is an analog temperature sensor used to measure temperature accurately. It gives 10 millivolt for every 1 Celsius increase. Also, it measures temperature in Celsius. And then it has 3 pins, which is VCC, output, and ground. VCC for power supply typically give 5 volt, and for output sense the temperature voltage, and let's say ground to ground. Why we use LM35? Because it's small, easy to use for PIC controller, Arduino, and my ESP32. And then commonly used in weather stations, cooling systems, smart home devices, and safety monitoring. That's all for me. And it also already calibrated, so we don't need to calibrate the sensor. So I will give to my friend.
Hi, my name is Muhammad Idin Shafi bin Jamaluddin. Okay, my focus today is on one very important part of the system, which is the signal conditioning. What is signal conditioning? In simple words, signal conditioning is the process of preparing raw sensor signals so that the microcontroller, in our case the ESP32, can read them accurately. FSR sensor and LM35 temperature sensor produce signals that are very small, not stable, and sometimes not linear. So before sending this signal to the ESP32, we must condition them properly. Then why we need signal conditioning for FSR sensor? for the FSR sensor, the resistance change when pressure is applied, but this raw resistance cannot be read directly by the ESP32. So the signal conditioning for FSR include the voltage divider circuit, filtering, and then for the scaling. This allows to microcontroller to convert the foot pressure into a clean and stable digital value. And then why we need signal conditioning for LM35 sensor? For the LM35 temperature sensor, the output is already in millivolts, but it is very small. For example, 20 Celsius give only 250 millivolt. So the signal conditioning may include amplification, and then noise filtering, and then lastly calibration offset. Then how it fits into our system? After conditioning, all the signal become voltage value that represent pressure, then voltage value that represent temperature. This clean signal are then sent to the ESP32, where they are converted into digital data. Finally, the ESP32 upload the process pressure and temperature reading to an IoT server link like Blynk or ThingSpeak, and the user can monitor real-time food data on a mobile app. Then, in conclusion, without signal conditioning, the data from the FSR and LM35 sensor would be noisy and unreliable. This test ensure that our system produce accurate food pressure and temperature mapping, which is essential for health monitoring application. That's all for me. Thank you.
Assalamualaikum warahmatullahi wabarakatuh. My name is Wan Muhammad Mirul bin Wan Azami. So, in our group, I will explain for the most important things in our block diagram, which is microcontroller. So, our group has chosen the microcontroller for our project is ESP32. So, why is it our group choose ESP32 for our microcontroller? The ESP32 is a powerful and low-cost microcontroller that is widely used in IoT application. It is chosen for our project because it has a fast processing capability and it comes with built-in Wi-Fi and Bluetooth, which is allow our system to send data wirelessly without using any additional communication module. One of the most important features of the ESP32 is its analog to digital converter pins, also known as ADC pins. So, these pins allow the ESP32 to read signals from analog sensors such as FSR sensor and LM35 sensor that we are going to use it in our mini project. The microcontroller converts the analog values from the sensors into digital data so that the information can be processed and analyzed. And then, after processing the readings, the ESP32 will transmit the data through Wi-Fi to our IoT platform, such as ThingSpeak or Blynk that we are going to use in our mini project. From there, we can monitor the pressure and temperature values in real time through graph on dashboard on the mobile phone or laptop. Another reason we selected the ESP32 is because it operates at low power, making our smart install more portable and suitable for continuous monitoring. It is also compact, affordable, and easy to program using the Arduino IDE, which makes development faster and more efficient for our mini project. So, for me, overall, The ESP32 functions as the brain of our system. It is because it will handle the data acquisition from the sensors, process the information, and sends it wirelessly for real-time monitoring. Without the microcontroller, our smart instrument would not be able to collect or transmit any data. So, for me, the microcontroller is the most important thing in our mini project. So, you want to know how look ESP32? So this is the ESP32 that we are going to see in our mini project. It has 32 pins at the right, 15 and left 15. Okay, that's all from me. Thank you and Assalamualaikum.
Assalamualaikum and good evening everyone. My name is Naufal Amshar bin Muhammad Zazri. For this project, I will explain why we use an IoT server in the system. Our mini project combines FSR sensor and temperature sensor to monitor human food pressure and temperature at the same time. To make the system more effective, reliable, and useful in real-world applications, we integrate it with an IoT server. There are 4 main reasons why an IoT server is important. The first reason is remote monitoring. Instead of viewing the sensor data only on a local display or serial monitor, the IoT server allows us to monitor pressure readings, temperature readings, and food condition from anywhere using phone or laptop. This is especially helpful if the system is used for medical monitoring where data needs to be checked frequently. The second reason is data storage. An IoT server keeps a record of all pressure and temperature readings over time. This historical data is important because food conditions must be analyzed through pattern. For example, consistently high pressure on one area may indicate a risk of injury. Temperature rising over time can show early signs of inflammation. With an IoT server, all this data is safely stored and can be reviewed anytime. The third reason is visualization. IoT platforms like ThingSpeak or Blynk can convert raw sensor data into graph, charts, gauge, and dashboard. This makes it easier to understand the relationship between pressure and temperature and to spot abnormalities quickly. The fourth reason is automatic alerts. An IoT server can send notifications when reading exceed normal limits. For example, the pressure become too high, the server can trigger an alert. If the temperature of the food increase abnormally, it can send a warning to the caregiver or user. This makes the system smart, responsive, and practical for real-life usage. In conclusion, we use IoT server in this project because it allows remote access, continuous data storage, clear visualization, and automated alerts. These features make our food pressure, temperature monitoring system more accurate, more practical, and more useful, especially for medical and health-related application. Thank you.
Assalamualaikum warahmatullahi wabarakatuh. My name is Novalini Sabinti Isa. So first, we'll explain about mobile app. So as you can see, our application goal is to transform the room, fuse data from the ESP32 into meaningful, actionable for food health insight. So basically the app is between the bridge. The app is the bridge between the technology and the user. So first, our application function is to pressure mapping visualization. So we display the data using the simple heat map, and then this is critical because users do not to interpret numbers, so they immediately see the red zone, allowing for the instant identification of high pressure area to prevent ulcers. So second is real-time temperature monitoring. So this is essential for detecting abnormal temperature spike, which are often the earliest physical sign of inflammation before the user. So the third is smart alert and notification system. So this feature sends instant push notification if the pressure or temperature reading exceed the safe threshold. So this enables early to detect and prompt intervention, especially for high-risk patients like those with diabetes, food complication. So lastly, historical data lastly we also include the historical data logging. This is important because it allows the user or clinician to track long-term pattern and monitor if intervention like changing their insole are effective over time. So to briefly summarize the final part of the data flow, the mobile apps connect directly to the IoT servers, which is ThingSpeak or Blynk, to retrieve the hosted data instantly. So this is how the real-time plots and alerts are generated. So in conclusion, the mobile apps is engineered to be user-friendly tool for preventing care. It is the vital link that transforms our sensors reading into a continuous remote for our patient. So that's all from us. Thank you.